And now I'm in position to talk about what is the maximum force. If I push F harder, as if I push F and the blocks go together, the accelerations are the same. I push F harder, the accelerations are the same. I push F harder, and I push F so hard that the static friction is no longer reaches its maximum value. And if I push F harder than that, I will not have, the static friction can't get bigger, and the blocks 1 and 2 will start to slip relative to each other. So my no slipping condition is that I want two things. A1 equals A2, we'll call that A, and the maximum force condition is that F static is equal to maximum value. Now, what is the normal force between that we refer to in our friction law? There's two normal forces, the ground and the normal force between the surfaces. But the static friction that we're talking about is between the surfaces, so that's why we use N here and not N ground. And now I can solve for this F max. By the way, we also have the condition that Fk is mu k. What normal force are we talking about? N, which we've called N ground 1. And now I look at my equations, and my goal is to solve for F. I know Ng1 from this equation. It's just equal to M1g plus N. I know N from that equation. So Ng1 is just the sum of the masses times g. So I know this. I have F, which is M2a. And I can now apply my result. So what we'll do is we'll solve for the A's, A1 equals A2, in terms of F max. So over here, we have that A is F over M2. That's from this equation. And now I'll substitute A1 is equal to that. I'll substitute that there. And I get that F max is going to be equal to Fk plus F static max. That's that one. Plus M1 times A1, which is F static max divided by M2. And so I get that F max equals, now I'm going to substitute in all of these values. It's going to look a little complicated. And so I'd like to have a little space here for that to get everything in here. And we'll see that it's equal to mu k m1 plus m2g, fk mu k plus m1 to mg, plus F static max times 1 plus m1 over m2. But F static max is mu n, and n is m2g. So I get m2g times 1 plus m1 over m2. And there is, if I push any harder than that, block 2 will slip with respect to block 1. Again, all of our terms have the dimensions of acceleration. This is dimensionless, 1 dimensions of acceleration. And we did miss one little thing. We missed the coefficient of static friction. And there we have it. Tricky problem.